If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE sponsored podcast. Hi.
Hey, I have a fun story for you to start us off just completely in a different direction.
Story.
So, I don't sleep much, right?
Yeah, almost never.
So early yesterday morning, we're talking late night, early morning, I was watching Jaws 3, which if you're not familiar, it was originally in 3D. It takes place in like SeaWorld, but also like a fictionalized version of SeaWorld that has this underground thing. That's not important to the story. What's important to the story, it's like SeaWorld amphitheater type setting. Then last night, I played my gig, the Jazzin' at the Shed Aquarium here in Chicago. And usually we play outside on the terrace, but I don't know if it was because they were expecting rain or something, but they moved us inside. For the first time, I played in the aquatic amphitheater. And let me tell you, I was like
Terrifying?
too soon after Jaws 3. Yeah, because the dolphins were going, the dolphins love the music, but their fins, can be mistaken for shark fins. So it was there were some very like scared, like bossa nova vibes that I was giving out, I think.
So life lesson, don't watch Jaws 3 and then go play inside of an aquarium. Promise, I will never do that.
Yeah. I'm Mercedes Landazuri.
And I'm Lynzie Nebel.
And with our powers combined, we are
PlastChicks.
The voices of resin.
Yeah, we are. And we have a really great interview today. This is a company that we actually got reached out to about, and I kind of was kicking ourselves, just myself, for not knowing about this company sooner, but I'm so glad we do now. And now we're going to do a whole episode on it. So I will be an industry expert. And I'm so sorry if that's not what I'm actually going to be, but it's too late. The train's in motion and I'm calling myself an industry expert. So today we have Sean Petterson, the CEO of Supersede, with us. Hi, Sean.
How's it
going? Great. We're really happy to have you here.
Yeah, so Sean, one thing that really stood out to me when you reached out and we looked up your company, and I don't think Lynzie and I even discussed this, but I was really impressed with the UX UI of Supersede's website, specifically with the material comparisons. I thought it was like really nice. And then looking deeper into your background, I saw that you went to RIT, which we've probably had some people from our engineers from RIT on here before, but then it all made sense. You actually studied industrial design. Is that right?
Yep.
Very cool. Very cool. So, so can you give us some background on Supersede and what brought you to founding this company?
Sure. I'm still caught up on the Jaws thing because it was the 50th anniversary of Jaws, so I have watched everyone on repeat the last 2 weeks.
Okay.
To my wife's chagrin. 3 is not the best, just saying, but I understand.
Oh gosh, yeah, and now I'm putting the pieces together with like Jaws and the industry that you serve. It makes total sense.
Yeah, it kind of does. It is sort of where it all came together. So I did go to RIT. It's where I met my co-founders, Jordan and Shane. And our background has a lot to do with water, has a lot to do with building. So I grew up on Long Island, where Jaws is supposed to take place, I think. At least I like to claim it is. And I grew up flipping boats. That was my first and only job. And then went off to school with the intent to design products that help people. So my first company, we manufactured exoskeletons, and then we made a big data product to help reduce injuries on the job. In parallel, I met Jordan and Shane, and Jordan had started a company that was making the first thermoformed jet ski. So the first jet ski to replace fiberglass with thermoformed plastics. And then, over the course of time, we always helped each other with our businesses. We both sold our businesses. And then the idea came around is just how do we build a better building material, and how can we do it in a way that has an impact on the environment? And so we started out looking at where are the most ubiquitous materials, the most common materials, because those will be the ones that'll basically ingest the most plastic. And that was plywood and OSB. And so it just so happened that the inherent properties of what we're building is that it's 100% waterproof. And that is a huge problem in obviously boat building. So we started and launched the company there with a marine board, and it worked out great. So yeah, that's our goal, is to make really good building materials that, you know, have an impact on the environment, meaning that we would like people to stop chopping down trees. That doesn't need to be for every material. There's better alternatives. And also we need to get rid of a lot of plastic that's ending up often in the oceans, right? I'm a diver and scuba diver, and we can be in the most remote locations and you'll see a Pringles cat float by, and that kind of ruins the moment a little bit. And so that's us. That's where we're starting.
I love that, you know, you basically you looked for where the biggest problem would be first. It's such a good place to start, especially I feel like some people go the opposite end and they're like, what's the smallest way I can enter this? And you're going, all right, where can I make the most impact right away?
Yeah.
And, you know, you said you're using this to solve a problem in marine manufacturing. You know, I think there's an easy answer to this question. You know, why did the gap exist until now? It's just that is the only material. But why do you think nobody's approached to this or even, you know, come close before?
Plastics have a bad name, specifically recycled plastics, right? And recycled plastics being that folks don't think they're as strong. You know, there's a bunch of things in there, and we said, how do we solve that problem first, right? So that was at just the material science level. And then it was what we're good at, which is the manufacturing and machine design and product design elements of it. So how do we optimize something, since we're operating in such a tight constraint? It's got to be a 4x8 sheet. And so using a little bit of AI, using a little bit of just good old engineering and a lot of process design, creating something that has the profile that enables us to create basically an I-beam structure. And so there have been, and there are other, recycled sheet manufacturers, but it's really difficult to scale and for the majority of the means that things are made today. And two, being structural is really the biggest thing. So we said, let's start out with the hardest challenge, and let's build something that's rated to be on a hurricane-proofed house, right? So our sheathing, we started out working directly with third-party testing labs to understand what are the requirements to get into building code. And the result was we actually rewrote some of the certifications. So we have our own AC standard from the ICC that says that this is rated for roof panels that can handle snow, wall panels, exterior wall panels that can handle the wind, and floor panels that can handle the weight of a home. And that was a pretty good use case, right? So our ultimate goal is to get into obviously all construction, starting with residential. But the use case right now is, let's prove it out in the hardest environments. So when we're working in boat building, a really common application is pontoon boat floors. And so that's the entire structure of the boat. So one, it's obviously getting wet, but two, you're hitting waves. So it's got to hold the chassis, which is proving the fasten retention. And then three, you've got people jumping up and down on it when you're on those waves. So now you're proving your impact and your span rating. So we're entering this market to really just prove what the capabilities are and the possibilities are for recycled plastics. And then we're going to take that ideology and spread it across all the other different niche applications and really broad applications, frankly, that we can apply it to.
So going back to that material comparison bit of the website that I was so enchanted by. Just really, really, really slick user interface there.
Thank you.
So on that, it looked like Supersede outperforms the marine grade plywood in water resistance, fastener retention, and I think durability as well, better protection against rot. Can you explain how those improvements were achieved? Did you have to go through different types of recycled plastics?
Yeah. So we have there's two different products on there. One is the Supersede Marine Board, which is, as you can see, it outperforms the status quo in basically every aspect. And then we have a product called the Yusta, and folks should know it's
The
just called
sheathing?
Yusta because it used to be something. That's how we came up with that name.
Solid name.
So what the and the reason I'm bringing up both is because there's a separate part of our process. So we have a dual extrusion process, right? So we're actually able to extrude a cap layer that's different from the core. And so allowing us to manipulate those two materials and how they interact with each other gives us different structures. So light weighting, strength for stiffness, or things that we're optimizing for, as well as general cost for implementation. So in that composite, we're selecting different materials for the core, and it's really just the idea that since we're building these machines and we're doing all this engineering, let's maximize the output of what we can do within that infrastructure, within those constraints. So that's how, getting to your question, we do the material selection process, right? So we're selecting around what are the core properties that the end product is going to be used for. Are we focusing on strength? Are we focusing on stiffness? Or are we focusing on weight? And all of those properties and how we're going to finally extrude it is kind of step number one. Step number two is evaluating where we can get these from within trucking distance, right? So we like to keep everything within a day's trucking. We'll go as far as 1,000 miles, but typically we like to keep it within 500 miles. And what we're looking for is things that we can get on a truckload basis on a regular schedule. And so there's specifics on what the overall output is, then there's volume specifics, and then we get into actually testing and batching the material. So now that what our goal is we want to broaden the spectrum in terms of the most amount of plastic that we can ingest. We typically start with a polypropylene, and that's usually a PIR. And that is just because it's a very dense material, it's got a very low melt flow, and it's very good for what we're shooting for in terms of very consistent batches in the early runs. We've really broadened that spectrum to include other types of plastics, other types of nylons, PETs, et cetera, that are in the blend. But then we have to make sure that we're able to ingest that. So what we do is we'll batch it. We have a miniature version of our lab a miniature version of our factory in our lab. And so we run it on a lab line, then we run it on a mini extruder, and then we test those properties. And then once we have that, we have our baseline of our core of our ideal material. And then we're able to adjust our dosing since we're doing everything in-house. So we're adjusting the compounding process to add the elements that bring it back up to par. Whether that be reducing melt flow, whether that be increasing impact. So we'll add those on a per batch basis. And then we'll say, okay, we have this source from this vendor that enables us to produce upwards of 2 truckloads a month, and this is exactly the formulation that works for this batch for this product, and we'll run that on that machine dedicated. So I hope that answered your question. That's a little bit of insight about how we work. Is that the reason that we're able to do this consistently and at scale is because of that internal compounding process where we're rebatching everything based on the specific use case and making sure it measures on QA. We're measuring it every 10 boards that we produce. We're taking them off the line. We're doing 3-point bends. We're doing impact testing and making sure that everything's blended correctly.
That's you kind of mentioned it with the fact that you're getting these materials from different suppliers and the batches can be different, which is why you're doing the lab testing first. That has to create some sort of hurdle in order to make these essentially recyclable boards that match performance or supersede performance.
Yeah.
And then also, but also remaining price competitive. How much of that 3-point dance were you trying to do, especially in the initial phases of this company?
Yeah, and I think that goes back to your first question, which is like how did we even get here, right? So we all went to RT, we studied engineering, industrial design. None of us on the founding team are material scientists, right? So we said we can bring in really good material scientists, and we've done that. We've been really fortunate to have some awesome guys on the team that helped through this process, but we focus our efforts on all the other pieces of the puzzle, right? So Shane's expertise is in designing the machines. And then, my expertise comes in realizing what the other part of the business is, which is it's logistics, right? This is more so a logistics company than it is uh, any of the other pieces of it, because you have to coordinate these things. We have to make sure that we're managing it through production. And at the end of the day, though, that goes hand in hand with the price point. So we can easily buy a frac mount PP on the open market from a consistent supplier, consistent vendor. But when we are looking at the environments that we're trying to displace, we want this to be ubiquitous, right? We don't want folks to be focusing on a green premium. We really want to have the impact, but frankly, we treat the environmental impact as like a selfish goal. And so this has to be cost competitive, and it has to outperform as a new player in a really old industry, right? And the players in the industry are gigantic. And so we've got to make a name for ourselves. And so in doing so, the vertical integration piece of it is really what's key. So designing the systems in our manufacturing process from cradle to grave in order to basically maximize our efficiency, reduce our waste, keep energy efficiency. All of those things are in the name of building a green product, but it's inherently positioned to actually create a profitable business for us. So we have to do them, which is what makes this a compelling business. So being able to source a wider range of resins and also in sizes, right? We'll take in bumpers, and we'll take in pelletized, and we'll take in regrind, and we'll take in flake, and we'll take in all sorts of sizes. And we just made sure that we built our infrastructure to ingest all of that, because a lot of this is a market opportunity, right? You have to strike while the iron's hot with a lot of these things. And so right now, for instance, we've got 4 container ships in the back of our factory in Phoenix right now, because the opportunity was there, and we just wanted to make sure we took advantage of a good price of a material that we vetted, and it ran really well, and the price was really good. So that's you're talking about some of the challenges earlier with why this hasn't worked, or I'm sure there's other challenges that we'll work into, but what we do know is that focusing on the logistics side, focusing on the ability to rapidly recompound elements that come in to meet our baseline performance is going to be the key to our success.
Yeah,
No,
I think that you called it a logistics side of it, because I don't think when you talk like recycled parts or recycled materials or anything, in the sustainability realm, I don't think most people think about that element of it. It's just like, well, why aren't you recycling more? And you're starting to hear people say, well, it's the infrastructure, but like the logistics of all of that is another piece that is missing from most things.
Yeah, it's the piece that needs to get solved, and then the other part that you need to solve is the person trying to get rid of it, right? There's not a ton of margin in it for them, right? You're reducing a headache for folks that are just trying to get rid of this, and that headache is, what we're competing against is this is going to a dump, and they have to pay the trucking fees is often our competition, right? And that's one, pretty sad, because this stuff is really good and has a long life, that we can reutilize it. But 2, it means that we have to be prepared to provide that, right? So if this person lost the ability for whoever was recycling it in the past to be the outflow for their waste stream, they're going to find something. They're going to find a solution, because they're not going to buy a warehouse to keep it in and wait for a buyer to come around. So we need to be there, and sometimes that means we're leasing grinders and shredders to some of these folks. We're putting them in their factories. We're gaylording that, and then we're taking care of logistics coming back, so that it doesn't end up in an incinerator or in a landfill or in a container ship going to another country.
Now, you have really emphasized the, wanting to build a truly green product. So can you talk, I mean, you mentioned a couple things here and there, but can you talk a little bit more about the circularity across the life cycle for your products from the raw material to the end of life?
Yeah. So the again, it aids our business model, right? So uh, while we're trying to be good for vendors that are bringing in, we're also trying to be good for customers. And so there's a huge issue, particularly with marine plywood, in that it's loaded with CCAs and formaldehydes. So in most states, and that's growing, one, it's getting banned, and two, manufacturing it, you have to dispose of it in line dumps in certain states. So there's a huge cost now for just taking your sawdust and chunks of offcuts and shipping them to a dump to be disposed of in a lined environment where they'll stay forever. So we saw an opportunity there to say, let's take all of your offcuts and put them in a Gaylord, and when we send a truck to deliver your next truckload, we'll take all that back. And so we'll actually pay the customer for that, so that there's an incentive for them to be responsible. And also it gives them, they're achieving their zero waste goals. So we regrind that, we reformulate it, and then we dose it back into our master batches.
That's
And then
awesome. That's really cool.
thanks. Yeah. And so we're, again, it's, it's incredibly efficient for us as a business. And I think that's how green businesses need to operate. We could talk about carbon footprint. I think that my challenge with carbon footprint is it's a bit of a red herring, in the sense of there are so many other things that we need to address in the planet. But the biggest thing is, if you want to cool the planet, stop chopping down trees. Old growth forests are nature's air conditioning system. And so keeping those intact is the best way to reduce global warming. But also, as we talk about the nonsense that's gone around in terms of carbon credits and what people have invested in, to assume that they're, at least present that they're green, it's all based on carbon sequestration, right? So if you're using wood and saying that you're sequestering the carbon, well, specifically with these tariffs, right, we're going to start harvesting southern yellow pine. And so that is a very, very young tree, right? It's a tree that we're chopping down that's probably 30, 40 years into its growth cycle, but that's a tree that could last for hundreds of years, sequestering carbon and scrubbing it out of the air. But we're saying in the first 20 years, oh, it sequestered 20 years worth of carbon. She's carbon negative. Let's throw it in a building and get some LEED certs. And that's nonsense, right? So we're saying cut that out, let the trees do their job. We've got something that's better, and it's using waste that's in the ecosystem today. And that's our biggest, promotion and being green, right? It's just getting folks, incentivizing with a better performing product, incentivizing them with a product that is cost competitive, and will fully address all those other challenges that you've been convinced are a good idea.
Yeah, that's yeah, as for every breath you can say that someone's greenwashing something, you can say, there's just so many elements of people that aren't necessarily paying attention, being confused by people saying like, oh, we're carbon neutral, or we're doing really good on the carbon. And I agree. I hate how the current system can be set up or can be manipulated to appear better than it really is. So I like your thought process and all of that. But one of the things I wanted to ask is, we hear people looking for recycled content or green solutions or anything like that. With your current messaging of using recycled content, is that resonating more with your customers right now? Or is it the performance of these, new materials, essentially? I'm going to say new with air quotes for those just listening. What message is getting across more?
The performance.
Okay.
Yeah, it's the performance. There are larger organizations, larger construction companies, larger OEMs that do have zero waste goals and do have carbon reduction initiatives, and do have downward pressure on manufacturing to incentivize more of this, right? But at the end of the day, we're in manufacturing, right? So we're working with production engineers on a daily basis. And when you're working in high-paced production environments, you can't add in extra steps. You've got to focus on, when you get through product engineering, if you're increasing BOM, that means one less thing that is sellable to a customer, right? And so we're seeing the customer care, right? The customer really cares about what's going into their boat or into their RV or into their home. And that is one, partially the environmental impact, but two, just the general overall hazards, right? So boats are made out of marine grade plywood, which is loaded with CCAs, it's loaded with formaldehydes, and they present the risk of you breathing all that in when they're off gassing, right? Those things get really hot. It's 180 degrees when it's sitting in the parking lot, and then you go and sleep in the cabin, right? And so that's important. On the other side, for pontoons, for things that are splashing against the water, all those chemicals slowly leach off. And if you're a local fisherman, what those impacts are because they're well known on the local species. And so we're seeing a growing push for the customer, the consumer of the product is actually certainly more educated and is really sort of expecting this to be table stakes for manufacturers. So as we push for our visibility, we're pushing for more transparency in what those manufacturers are putting out into the market. And then in the larger companies, that continues to push itself through, but frankly, the markets across the board are down, right? Like sales for boats are down 10% this year already, just given the current, economic conditions. And when you do that, you got to make cost decisions. And, unfortunately, things with a green premium just aren't going to cut it. So, our goal is simply focus on making a better product, knowing that if we scale it, we'll have our selfish goals of making a real environmental impact. And I think that's just the name of the game. And that's how green companies have to perform, particularly in this environment.
Mm-hmm. Now, speaking about some of those, I mean, we've seen increased interest and even consumer interest in chemicals of concern. And in the United States, it's done on a state-by-state basis currently for the most part, right? We've seen like PFAS starting to get phased out.
Mm-hmm.
Do you anticipate upcoming regulations that will accelerate a shift towards material solutions like the Supersede Marine Board?
Yeah, certainly. There's an interesting one. There's a bunch, but a good one is California banned the use of formaldehyde, right, to a certain percentage, right? It's like less than, I don't know, 100 ppm or something like that. And that is obviously a major component of the marine grade plywood we just talked about. That's typically used in the transoms of boats, so where the motor hangs off, and then it's wrapped in aluminum for certain aluminum fishing boats. So in order to kind of subjugate that, they had to increase the CCAs that were embedded, right? And those are the two main components of waterproofing. Chromiated copper combined with salt water creates electrolysis, and now it's dissolving the aluminum in the boats. So as regulations push things, there are adverse reactions, and folks are sliding to us just to avoid what's up and coming. And so that's been a big one when we're selling into those folks. And then obviously LEED certifications and other things that are going to continue to drive general interest. I do think that with things like the Big Beautiful Bill, there's actually going to be a bit of an adverse reaction in a lot of things. But there will be a resurgence of domestic manufacturing. And so we're just hoping to be a proof case that you can create a really healthy, stable business that creates a really good product that also has a good impact. And I think, that's the line that we're towing, because it is unclear. where the pressures on large organizations is going to come in terms of some of these new regulations. But there is undoubtedly already an educated consumer, and the consumer is becoming more aware of what's going in, and they're having more of a voice. And I think that's more important than, the bottom line for some of these companies, right? Customers really do care. We're going to push out a survey that we did on those customers, and the results for me, honestly, were really inspiring. I think mind blowing, sort of, to see how much people really do care. And I think so. Following what the consumer wants is going to be what's most important, and then for the OEMs, it's building a good product.
Yeah, I mean, that makes a lot of sense. And I love that you guys are taking that feedback from your customers as well. But it looks like you guys just finished up a fresh round of funding.
Yep.
And so what are some of the key initiatives that that's going to support with you guys?
We're building a second plant. That's the biggest thing.
Big one.
So yeah, a big one. But it's actually a big relatively, right? So it'll be 3 times the size of our current plant. So, but that will be the model for us to scale there going forward. So the big initiative for this right now is to prove how quickly we can stand these up, and how replicable the process is in terms of we're standing this up in an area where there's ample plastic waste within 500 miles or less. So within a trucking distance that we can clean up that radius that we're going to be serving in. But that'll also be the blueprint. So we don't think that having a gigafactory in the middle of the country is the right model for anybody, right? All that trucking, all that extra waste that's going in the system, all the extra energy that has to be expelled. It doesn't make a lot of sense. We want to locate these factories, and we're going to build multiple of them near the sources of recycled plastic and the end user. And so this next factory is just going to be the blueprint for us to scale. So we're going to build this one, and then we'll build 2 more after that, to show that we can build 1, and then we can build 2 in parallel, and then we'll scale that model going forward. With the idea being, the ideal scenario is around 6 extruders in a location that is where we can employ folks that are building products that are cleaning up their own local environments, and that's our goal.
Now, looking ahead, how do you envision the broader adoption of innovative plastics for heavy duty sectors like marine and RV? Are you so currently you guys are marketing just to OEMs, is that correct?
Mm-hmm. Yeah. And the reason for that is it's highly replicable in terms of the sales process. That'll serve as our revenue base. And it is a recurring business of consistent volumes, right? Because we extrude it, we're able to do it at any custom length. So folks are building it and buying it in odd lengths that fit their production needs. So our ability to send truckloads at a time of a unique length is efficient for us. And also it's just a more of a guaranteed and stable revenue base. And then the ultimate goal is to obviously get into construction. Next step, we're doing some factory built work. And same scenario where folks don't want wood in their builds, and I think that's great. There have been a number of composite initiatives for the last several decades, but nothing can meet in terms of the performance of wood in the onset in terms of strength, and the cost is just nowhere near it. So we're in that ballpark, which is why we have a really exciting path forward. And for us, starting in an arena, a ballpark that we can win in, being in OEMs and being in this market that's about 1/100th of the size of the overall opportunity, means that we can earn a lot. We can earn our stripes. We can earn a stable revenue base. We can stick it in environments where it's going to get really beat up, right? We're going to really put this through the test and serve as a great base case. And then, you know, do you want a house that's waterproof and lasts longer, and is good for the environment? I think, you know, it's a pretty good value proposition as we move forward.
Mhm. Now, do you imagine as consumers get more comfortable with using plastics, recognizing plastics in some of these applications, right? Because a lot of times we don't even recognize that plastics are there if they're doing their
Yeah.
job, right? Do you imagine that as consumers get more comfortable and aware of plastics being used in some of these applications, that we might start to see these types of materials as wood alternatives at like a Home Depot or Lowe's, that consumers are actually choosing over wood?
I hope so. That's the plan. You know, we would love that to happen. And for us, that's a big reason why we're driving scale, is to make sure that we can meet those types of demands. It's that is certainly the goal, and that's really where the idea of the company started, was looking at the racks and the product inconsistencies, at your local, you know, wood distributor. And also when you think about the waste, you know, when you get a pallet of wood dropped off at your house for a build, the bottom pallet and the top pallet always goes in the garbage because it's getting wet and it warps. And also, wood really doesn't perform well after it gets wet. So that's a big thing that is, uh, like a weird little industry secret, right? So marine plywood we'll use because we're going directly, at that today, and that's supposed to be waterproof, right? So we do a lot of studies here, and we've replicated this study over 50 times. And what we do is we take a sheet of plywood, we soak it for, you know, 4 hours, and then we let it dry. We've soaked it for 30 minutes. We've soaked it overnight, and we've constantly replicated this process. And in every time, what we see is that the wood, first of all, still gets wet and still absorbs water. When it completely dries out, or after some cure period, when you would think it would go back to normal, it loses 30% of its strength. And so that's because when all the fibers that were compressed and they were bonded together, all the wood swelled and all those bonds broke apart. Now you have a weaker material. So when you're building a house and you've got this spec rated sheathing that you paid extra money for, and now your build went on pause for a week because it was raining, or you're building a ski house and a snowstorm came in and dumped on your roof, that roof is now significantly weaker, right, than what you bought for, right? Even if you paid extra money for the fancy stuff that was supposed to be waterproof, your house is weaker, right? And that's right now, it's the boats are weaker. Folks need to know that, and that's something that we are really making sure that resonates with folks, particularly when you're talking about a boat where the floor is the wood and you're standing on that and your family's standing on that. That is significantly weaker than what it was spec'd for. And so I think just, you know, I really hope the green initiative helps us along, but it's a safety factor, right? You know, you're letting mold propagate in these things. You're letting the weakness of the wood be a part of your overall structure. And also, you know, while they're warping and they're creating all these inconsistencies, it's just creating a failed build down the line. So, you know, the way that we see it is we're giving plastics their forever home, and we're also, you know, building you a forever home, right? Because it's just going to last that much longer.
That.
I have to say that the question about Home Depot and Lowe's, about these types of materials being available there, is kind of selfish on my part.
It was.
Well, you know, so looking into your material and comparing it. So I live in Chicago. The weather here is terrible, and I got into skateboarding a couple
You live in
years
Chicago?
ago.
Oh,
Yeah.
I just got off the plane from Chicago. That's why
Oh,
I
no way.
look sleepy and I'm ragged. I ran here from the airport.
Well, yeah, so I got into skateboarding a few years ago, and I've been thinking about building a ramp.
Nice.
But
Yeah.
wood does terrible in Chicago.
Yeah.
These wooden skateboard ramps, we have one at a skate park that's like under an underpass, and it's just all splintered, it's cracked, it's like completely warped, you know.
Yep.
And I'm like, well, what would be the point? I could use it for maybe 6 months and then it would be toast, even if I kept it covered, you know.
Oh yeah,
But
100%. So
mhm.
I skate as well, and so does
Nice.
Shane on the team. And you get two choices, right? You get a metal park, which if you've ever skated in a metal park, it's horrible. It
Yeah.
hurts in every aspect, and it gets really hot. And then you've got your wood parks, and then you've got your concrete parks, and concrete parks are prohibitively expensive.
Hmm.
We're super lucky in Arizona. We've got a lot of really great ones. But yeah, I would love to actually have, I don't, maybe you can figure this out. We would love to donate some to any parks that are going up. Because wood parks are easier to build, obviously, but they don't last. Ours will last. The surface is really good for skating on, and you can kerf it, right? So our boards will bend, and if you countersink it into the surface, you don't need skate light. So it'll actually be a cheaper build too.
Hmm.
So instead of having your plywood, then your skate light, we can just be the one material. We can be the supports in the structure. And we really want to, we haven't had time, but we really want to build a mini ramp at the HQ. That's our goal.
Oh my gosh. Well, when you do,
Yeah.
please, I need to come
Mercedes
and
needs
skate
to
it. I
try it
will
out.
be. I
Okay.
She's
will-
Come on down.
only broken her collarbone
Plant tour.
once.
No, I never broke my
Perfect.
collarbone. I broke my shoulder when I was brand new, just
Up here.
outstretched before I learned to like roll it out. Yeah. But yeah, no, here's proof. Just where is it? Just
Nice.
the other day. I know, like I rolled it out yesterday. I don't get hurt anymore. Just little scrapes. But yeah, I mean, yeah, that's awesome. Of course, it's a much smaller market. It makes sense that you're going after, more of an industrial,
Yeah.
but first. But this really, really exciting stuff. And I'm so pumped that you skate as well. I need you guys to make a mini ramp, and I will be there.
Yeah. We've made a skateboard, but mini ramps next.
Oh wow.
I'll come and watch. That's my
All right.
contribution.
Perfect.
Well, Sean, thank you so much for being here today. This has been an awesome conversation. I'm so excited about your product and the goals you guys have and the expanse that you're building to. I think it's a really great thing for the industry and just for the marine and RV and potentially skaters in the future.
Yeah, hopefully that's the plan. Thank you so much. It was great to talk with you guys. This was really fun.
If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE sponsored podcast.